Let's have a look at what are the components of the MP160 system. First of all, we have the MP160 itself that connects to the AMI 100D. To power the system, we have a power cord and a power supply. Then there is also an Ethernet cable, which you can use for direct connection to the computer or connect it to a hub that's connected to a computer. For a direct connection to the computer, you can use the supplied Ethernet USB adapter if the computer does not already have an Ethernet port, or if you want to use the Ethernet port for something else. So these are the components of the system. Notice that the MP160 and the AMI module, they simply snap to each other. That's how it works with most of the components of the system. They just snap to each other via these connectors. There is a 37-pin connector and there is a 25-pin connector. And usually there is only one way the modules can snap together. So if they snap, then it's a viable combination. You can actually connect modules on and off even when the system is running. Let's look at the back of these modules. So here is the back of the MP160. And we can see now we have an Ethernet port. So we would take our Ethernet cable and we would connect that to the Ethernet port. This would go via this USB to Ethernet adapter to the computer that's going to run the acknowledged software. To power the system, we have the power adapter, which connects right here at the back. And then we have a power cord. The power cord connects right here. If you don't have the correct power cord, you can just use a local one because it's a pretty standard computer connector. And that's it as far as what the system looks like. Just a few words about the MP160 itself. This module is the analog to digital and digital to analog converter. This is what records the systems. This is what provides output. The AMI 100D module has direct access to 16 of the channels. These are the analog channels, and these are the inputs, and these are the outputs. Okay, and then from here on, we snap on additional amplifiers. So ECG 100C, EMG 100C, all those amplifiers have a 37-pin connector that you can easily snap on and connect to the rest of the system. I'll go now and grab one of those amplifiers. So this amplifier right here is an EMG, this is an EMG 100C amplifier. Notice how the amplifier has the same kind of connector. Here we are viewing them side by side. So I can just align and snap them together. Alright, so now all these amplifiers are snapped together. In this fashion, you can keep extending the MP160 system and add more and more amplifier modules. You have a maximum of 16 analog channels because that's the limit of the system. Now here, to this connector, we can connect the electrode leads. So specifically, if connecting to the EMG 100C, we would connect the MEC 110C extension cables and the corresponding leads. Let me grab those. this right here is the connector. This right here is the connector MBC 110C. So it simply snaps on here like that. It's very easy. And then you can see it's a long shielded cable terminating with electrode leads. So we can see here the other end of the MEC 110C connector and the different electrode leads. So the black one goes to ground, and plus and minus are indicated as well. If we follow all the way to the other end, we shall see what the cables are terminating in. So the cables are terminating in these connectors. Okay, these clips are what snaps on. They snap on to the actual electrodes. Okay. Let's have a look again at the amplifier. Each amplifier has gain selection, so you can change the amplification. For ECG, we typically use 1000 or 2000. Then we have, for EMG, we have these different positions, and it depends on the muscle actually that we're measuring from. So for big muscles in the body, yeah, 1000, 2000 is quite good. Facial EMG, we go to 5000. Then we have some options for low pass filtering, so we can either have 500 Hz or 5 kHz. And then for high pass filtering, we have two different options. Either we use the 100 Hz high pass filter, which is quite aggressive. It's not very commonly used. Or we use 10 Hz or 1 Hz. Okay, so we have to select our switches accordingly. Let's have a quick look at the top of the amplifier here. Okay, so we can see this channel selection switch. As I mentioned before, there are 16 channels in the system. So right now we are set to channel 1, and now we are set to channel 16. We have to make sure every amplifier has a unique channel selected. Otherwise there will be channel conflict, so you have the same amplifiers writing to the same channel. Now there are also other kinds of amplifiers which we call smart amplifiers. Those amplifiers connect to the front of the system. We can see here a box of a smart amplifier. Let's go ahead and open it up. This is a smart amplifier or D-series amplifier. Let's put it to the side here. We can see how small it is. This is the physical size of the D-series amplifier. This one is for facial EMG. And these amplifiers have a connector that just snaps on to one of the channels like that. Okay. So this is now connected to channel 1. So you can no longer connect this amplifier to channel 1. You have to change to channel 2, for example. Making sure you avoid channel conflicts is very important. These amplifiers, the smart amplifiers, they connect to different kinds of leads. They're the same leads that we use for the bioinomatics modules. I'll go ahead now and grab some leads for bioinomatics. So now we can see in my hand, these are the leads for bioinomatics. They're much smaller than the other leads that we used for the C-series amplifier. They connect both to the smart amplifiers and to the bioinomatics. Okay, so we can see here now the connector. The other kind of amplifier we have is the wireless amplifier. So I'll go ahead and grab a wireless amplifier. This particular amplifier, let's have a look at it. This is the pose and skin conductance amplifier. It's called PPG-ED, which stands for pose and electrodermal activity. You can see now you have to connect it in a different place because this amplifier has 37 and 25 pin connectors. So we'll separate these modules, okay, so that the amplifier can be in between the modules. Okay, so now it's right here. And what we have at the moment is a system that contains both wireless and wired amplifiers. You can see here the antenna of the wireless amplifier. So it consists of two parts. There is the receiver here, and then we also have the transmitter. It's the transmitter that is worn on the participant, and it communicates with this module. So we make sure our channels are correctly set up. We know the EMG was on channel 1, so we would set up the pose and EDA to make sure we do not have a conflict. So we can't be on channel 1, so we're now on channel 2, and then we have options here for PPG EDA. We can turn on and off the PPG or the EDA, and we can change the combination of channels. So this module, let's turn it on here. This is the transmitter module. This is worn on the participant's hand. So let's have a look how that works. I'll put it on. Okay. So like that. Now it's transmitting to the main unit. And you can see here the connectors. Okay. So the same bioinomatic style connectors that we use for the smart amplifiers. So electrodes would connect to here, and they would go for EDA, they would go to our electrodes, or if we're using a pose transducer, so from here we'll connect from the pose transducer to be worn on the finger of the participant. The same principle applies for all the other wireless modules.